Hello everyone, in today's video we'll be going over a number of sample problems on geometric series. Okay, so like always, I'll go ahead and first write down the formula, the main formula, primary formula that we'll need for this section, and that is that Sn, the sum of the first n terms, is equal to the first term times 1 minus r to the n over 1 minus r. It's also good to remember the nth term formula for geometric series and sequences, which was r to the a times r to the n minus 1, like this. Okay, and of course we've already gone over the lesson for these two formulas, explaining where they come from and how to use them, or rather what they mean. If you haven't watched those, you should go back and review those videos. Today we'll primarily be dealing with how to use this formula. All right, so let's have a look at the problems. It says find the sum of the first 5 terms in the geometric series 2, 6, 18, and 54. Okay, so this is a simple use case of using our sum formula. Okay, so we're just going to be using this formula. We want the sum of the first 5 terms. Okay, so we're going to have to do the first term, which is 2, times 1 minus the common ratio. What's the common ratio here? The common ratio is 3. All of these are being multiplied by 3 to get to the next term. 3 to the power of n. N is 5 because we want to find the sum up to the 5th term, and we'll do 1 minus 3 here. Okay, so this is all that we have to do. So now let's simplify this. This is going to be 2 times, let's see, so 3 to the power of 5 is 243, and 1 minus that will be negative 242, all over 1 minus 3, which is negative 2. The negatives cancel out, the 2's cancel out, and we get that S5, the sum of the first 5 terms in this geometric series, is 242. Okay, like that. All right, let's have a look at the next problem. It says for the geometric series, this guy find the number of terms and the sum of the series. Okay, so how do we find the number of terms? We've went over this technique before, but if this is the first term, this is the second term, and this is the third term, suppose that this is the 15th term. Okay, if that's the 15th term, well, that means we have 15 terms here, right? If the final term is the 15th term, that means we have 15 terms overall. So our first task is to figure out which term number this is. And for this, we'll use the nth term formula. So that's the one that goes like this. Okay, I know my nth term is 1215. My first term, a, is 5, and the common ratio here is again 3. These guys are being multiplied by 3 every time. So it's 3 to the power of, and I don't know which term this is, right? I don't know if this is the 10th term or 15th term. So I'm just going to have to leave an n there. Okay, and we've done problems like this in the previous set of sample problems that I worked through. Okay, so if you have any issues on this, please go ahead and watch that. But I'll quickly review how to do this problem. So we'll first divide both sides by 5. So let's see, 1215 divided by 5. That's going to give us 243. Is equal to 3 to the n minus 1. Now we have to write both sides in terms of a base of 3. So I have to express 243 as 3 to the power of something. And we can do this using logarithms, but I haven't done a video on logarithms. So for now, we are going to do this using a factor tree, or simply guess and check would also work. So I think 3 to the power of 5 should work here. 3 to the power of 5, yeah. So this is the same as 3 to the power of 5, 243, and that's equal to 3 to the n minus 1. So if these two bases are equal, and the right-hand side and left-hand side are to be equal, that means their powers also have to be equal. Okay, so that means we can say 5 is equal to n minus 1, meaning n is equal to 6. So this is the 6th term, and there are 6 terms in this series. Okay, let's erase this now and answer the next part of the question. So there are 6 terms. We'll do n is equal to 6. We found the number of terms. Now we want to find the sum of the series. So this is the sum of the first 6 terms of the series. So that means S6 is what we want to find. And that's going to be equal to the first term, 5, times 1 minus the common ratio, which was 3, to the power of the number of terms we're summing up, which is 6, all over 1 minus r, which is our r was 3. Okay, so this is going to be equal to 5 times, let's see what 3 to the 6 and 1 minus that. So this is negative 728 all over negative 2, and let's see what this comes out to. So times 5 divided by negative 2, that's going to be 1,820. That's what the sum comes out to. Okay, so 6 terms, and this is the sum. Okay, let's have a look at the next problem. It says calculate the sum of the geometric series with 6 terms. Okay, so they tell us how many terms they want the sum of, so we can just simply say S6 is equal to the first term, 4, times 1 minus, what's the common ratio here? Well, in order to go from 4 to negative 12, you have to multiply by negative 3, so times negative 3. And in order to go from negative 12 to positive 36, again, we can see we multiply by negative 3, right? Negative times a negative makes a positive here. Okay, so hopefully that's clear. Let me put these in brackets. All right. So the common ratio is negative 3, and we put that in brackets and raise it to the power of 6. So this is actually a somewhat important thing to point out. You have to make sure that when you're raising the common ratio to the power of your number of terms, it's the common ratio including the sign it has. So in this case, we had negative 3, so we have to do negative 3 whole thing to the power of 6. What we shouldn't do is cancel the negatives, put positive here, right? Because if we have 1 minus negative 3, that's the same as 1 plus 3. So what we shouldn't do is write 1 plus 3 to the 6. That would be wrong. Okay, so let's change this back to the original. Okay, and this whole thing is over 1 minus negative 3. All right, let's simplify this. So this is 4 times, let's see what negative 3 to the power of 6 is. So negative 3 to the power of 6 is the same as 3 to the 6 because this is even. So that's 729, and 1 minus that is negative 728. On the bottom, we have 1 minus negative 3. That's the same as 1 plus 3. The two negatives cancel here. So that's 4. Okay, the 4's cancel, and we get that S6 is negative 728. All right, next problem. It says find the 8th term and the sum of the first 8 terms of the geometric series, where A1 is 7 and R is 3. So the part where we are finding the 8th term, isn't important for finding the sum, and doesn't really have to do anything with the sum unit, the series unit. I mainly just put that there just to make sure we still remember how to find the nth term. So what is the 8th term? That's A8. That's equal to the first term, 7, times the common ratio to the power of 8 minus 1. So A8 is 7, 3 to the power of 7. So let's see what this comes out to. So 3 to the power of 7 times 7. So the 8th term is 15,309. Okay, that's the 8th term. Now let's find the sum. Okay, so what is the sum of the first 8 terms? So S8 is equal to A1 minus R, so 3 to the power of 8 all over 1 minus 3. Okay, so this is 7. 1 minus, let's see what this comes out to. So 3 to the power of 8. Okay, and then 1 minus that, so this comes out to negative 6,560 all over 1 minus negative, or 1 minus 3, that's negative 2. Negatives cancel, and this will come out to, let's see, times 7 divided by 2. This will come out to 22,960 for the sum. Okay, so that's our sum. That's our 8th term. Let's go on to the next problem. It says for this series, find the sum of all the terms. And by all the terms, it means up to 192. Okay, so we want sum of the first how many terms? Well, we don't know how many terms there are, right? Because I don't know if 192 is the 10th term, the 12th term, or the 100th term. So the first step is to figure out how many terms we have. Okay, and again, to do that, all we have to do is figure out what the term number for 192 is. If 192 is the 15th term, that means we have 15 terms here. So this is just like the one we did above and in the previous worksheets, previous videos. So I'll go through it a little bit faster. So we're going to say 192 is equal to the first term A times R. The common ratio here is 2 to the power of n minus 1. I'll divide both sides by 3. So we get 192 divided by 3. That's 64, and that's equal to 2 to the n minus 1. We have to write both sides so that they're both in terms of 2 to the power of something, right? So they both have a base of 2. So 64, I think, is 2 to the 6. Let me just double check that. Yes. So 2 to the 6 is equal to 2 to the n minus 1. That means that 6 and n minus 1 have to be equal if the right-hand side and the left-hand side are to be equal. Right? So in order for those to be equal, 6 has to be equal to n minus 1, which means n is 7. So we have 7 terms here. Right? This is the 7th term. Okay. Now let's find the sum. So the real question was to find the sum of all the terms. So S7 is equal to the first term times 1 minus the common ratio of 2 to the power of 7 all over 1 minus 2. So this is going to be 3 times, let's see what this comes out to, 1 minus 2 to the power of 7. This is negative 127 all over 1 minus 2, that's negative 1. The negatives cancel out and we get 3 times 127, which is 381. So S7 is 381. Okay, let's do the next problem now. So for this next one, it says find the sum of the geometric series that guy, where the 8th term is negative 3,200. Okay, now for this problem, we don't really need to know that the 8th term is negative 3,200. All we need to know is that there are 8 terms. And so to find the sum all the way up to the 8th term, sum of the first 8 terms, we do first number times 1 minus the common ratio, and the common ratio here is negative 2, right? Because we can see every time this has to be multiplied by negative 2 to get to the next number. So negative 2 to the power of 8, whole thing divided by 1 minus negative 2, the common ratio. Okay, so let's work this out and see what we get. So that's 25. And let's see what 1 minus negative 2 to the 8. So this is going to be negative 255 all over 1 minus negative 2. The negatives cancel out. That's the same as 1 plus 2, or 3. Okay, now let's see what this number is. Times 25 divided by negative 225. 255 divided by 3. Okay, so this will come up to negative 2,125. So this is the final answer. Why is the final answer negative? Well, because in this geometric series, we have negative numbers as well. And just the way it works out is when we add all the terms up here, overall, they come out to be a negative value. Okay, let's do the next problem. It says determine the sum of the geometric series 2, 10, 50 with 5 terms. Okay, so we know that there's 5 terms here, so we can simply do S5 is equal to the first term times 1 minus the common ratio, which is 5, to the power of 5 all over 1 minus 5. So this will be equal to 2 times, let's see what 1 minus 5 to the 5 is. So this is negative 3,124 all over, down here, negative 4. So the negatives cancel out, and we get, divided by 4. We're going to get 1,562. So S5 is equal to 1,562. Okay, so that's where I'm going to pause for this video. There's going to be a part 2 for this video where we'll work through the word problems as well as another section that I had here with the advanced problems. Okay, so in the next video, part 2 of this, we'll be going over that. See you in the next one.